Here's the solution to homework set number 8 for ECE 341. This covers queuing theory and normal distributions. The first problem is, suppose you're running a fast food restaurant and customers are arriving with an exponential distribution with a mean of 90 seconds, and the time it takes to service each customer is also an exponential distribution with a mean of 60 seconds. Run a Monte Carlo simulation for 1 hour and determine what's the wait time, what's the queue size. Well, this is where Excel really comes in handy. In Excel, get this dimension for the screen. What you can do is set up your different cells. So here, the first column are my customers, and we'll start at -9 because some of the later formulas are going to find out, is my arrival time less than the time the previous customer served, or the previous customer, so on. So I'm going to go 9 in the past, and these are just a bunch of zeros. For customer 1, the arrival time is exponential, and that is 90 times the log of uniform distribution, minus 90. One way to do that in Excel is if I do a $sign, that locks the cell. So $B, $1 says this is always element B1, 90 times the log of a random number, rounded to the nearest integer. And there's the second one, third one. And notice that the first entry, B1, is always locked. That's always this number right here. So I can sit there and change the arrival time. Let's make that 100 second mean time. It'll recalculate a bunch of random numbers with that. The service time, likewise, is an exponential distribution with a mean of 60 seconds. This just does locked cell C1 times the log of rand. The total time that you arrive is the time of the previous customer plus 141 seconds. So this will be 114 plus the previous customer, 9 plus the previous customer, 76 plus the previous one. The time that I'm served is the maximum of when I arrived and when the previous customer is finished. So like right here, I arrived at 264, but the previous customer wasn't done until 288. So that's when I'm done. The time that I'm done is the time that I'm served, cell E, plus the time it takes me to finish, cell C. And the wait time is the difference. When am I served versus when I arrived? The queue size is then checking. When did I arrive versus when did the previous customers get finished? If this is less, well, how many of these is it less than? So that's just kind of a Boolean. Is D15 less than the previous one, previous, and so on. And for fun, I'm just kind of plotting it. So that's kind of what you can do in Excel. Nice thing about Excel is you got to see what the cells are, the formulas. You can also sit there and change it. So here, let's see, why do I want to do this? I want to get rid of that header. Get rid of this too. Here's the wait time and the queue size for what was asked. And every time I type in this, it's going to recalculate a bunch of random numbers. And notice that when the service time is really small, the queue size is typically 0, maybe 1 occasionally. As the service time gets bigger, this wasn't asked for in the homework, but it's kind of fun to play with. It's not really a problem. When the service time is about half the arrival time, I start getting fairly large queues. The queue size is 4. Now it's getting up higher. And if the service time exceeds the arrival time, so people are arriving faster than I can serve them, I kind of get this graph. The queue size keeps on building, 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 and goes on without end. The wait time keeps on getting longer and longer and longer. So that's one problem with queuing theory. You got to make sure that you're serving the customers faster than they arrive. And if it's just a little bit faster, that still doesn't really help, because just by chance, you might have a bunch of customers arriving all at once, so the queue can build up quite a bit. And it tends to be right around half to 2/3. I want to make sure that my service time is about half to 2/3 of the arrival time. Otherwise, the queues start getting really large. So that was problem number 1. Problem 2 is if I have a 6-sided die and an 8-sided die. I calculate the mean, calculate the standard deviation, calculate the variance. If I roll 5 6-sided dice and 5 8-sided dice, the means add. So it'll be the 5 times the mean of a 6-sided die plus 5 times the mean of an 8-sided die. The variance also adds. It's not the standard deviation, it's the variance that adds. So the variance is 40, square root of that is 6.38. From that, I can come up with a 90% confidence interval. From a normal distribution, it looks like this, to get an area of 90%, I need to go from the mean left 1.645 standard deviations, and right 1.645 standard deviations. So we'll take the mean plus minus 1.645 deviations, gives you this range. So 90% of the time, I should roll numbers in that range. And it can also calculate. What's the probability of getting more than 49.5? What I do is I take what's this distance, 49.5. How far is that from the mean in terms of standard deviations? That's 1.48 standard deviations away. From StatTrack, 1.48 standard deviations has an area of 6.9%. I can check that. Run a Monte Carlo simulation. I'm going to roll 5 6-sided dice plus 5 8-sided dice, add them up, count. How many times is sum more than 49.5? Repeat 100,000 times, and I got 6.9%. And for weather, from Hector Airport, we've got the temperature in Fargo, the max, min, average. Look at the maximum for the month of July. The average maximum since 1942 is 94 degrees. The standard deviation is 4. So to find out what's the chance it's going to break 100 this July, I've got the average is 94 degrees Fahrenheit. Here's 100. I want to know what is this distance in terms of standard deviations. That's called the z-score. So that's the distance 100 is in terms of standard deviations is 1.34 standard deviations away. From StatTrack, I can look at a normal distribution and find out what's this area when I'm 1.34 standard deviations away, and that area is 9%. Or a lot of people found the other area. This is 91%. All probabilities add to 1. If the right tail is 9%, the left side is 91%. So that's homework set number 8 for ECE 341.